We're live. I'm quite excited. And we are live. So this is the first day of the 2019-2020 school year. And if I don't look the same, it's because I'm not the same. I've lost 35% of my mass. So that's as far as we'll talk about that. So out here, in just case you think we're not live, here's my... Yeah, we're here. And I usually have some intro music, and I'm going to see if I can find it here. I did have it. I bet you I lost it. I don't know what happened. How did that lose? Oh, let me do this again. Oh, I know where it is. So here we go. And I don't know if this will even work. Because again, this is technology. Usually I do this on my phone, but I've kind of been anti-phone. Yep, just wait, just wait. I usually have a theme song I start out with. And then hopefully I won't be kicked off the internet. Here we go. I think I'll do it for the 21st time. There we go. Yeah, a little corn. It's August. A little corn doesn't hurt. All right. So, was I talking yesterday about driving? Or, see, I get this class in third period. How many people have driven on a highway? Okay, great. Josh, I'm going to pick on you. What's your favorite highway to drive on?
15.
Highway 15. Excellent. As you're driving Highway 15, do cars pass you?
Yes.
Okay. And sometimes you see a car on the side of the road that raises the concern of everybody driving. Can you give me an example? Just sitting there. A police car. Correct. So what do you notice people do? They slow down, right? Would you agree? Okay, slow down. Why are they slowing down?
Because police cars usually mean caution when something is wrong.
Okay. I would agree. Is there another reason they slow down?
It could be speeding.
They could be speeding. Okay, would you agree?
Yeah.
What's speeding?
Going over the limit.
Okay, exceeding a limit. Yeah, you want it like this so you can actually read what I'm writing? Yeah, it's a great idea. So that's your job. Okay, your editorial control. Okay, good luck on that. Okay, I'm going to unplug this too because I'm going to kick it with my foot. So since Highway 15, Josh, and you don't mind me picking on you, do you? Yeah, because it's not going to change. And since Highway 15 is your favorite highway,
Yeah.
what is the speed limit on Highway 15? 60. Okay, would everybody agree? All right, now, this is what I do. Real world scenario in which I'm going to talk about limits. Because to me, limits are really abstract. So give me an example of someone you would observe exceeding the speed limit that has to move to 60. What speed limit would they be going that would cause them concern by a police officer or highway patrol? Josh?
Like, technically it should be 61.
It should be 61. Are you concerned if you're going 61? No.
I'd be concerned.
So you don't have to be exactly at 60.
Yeah.
Would everybody agree? You could, if you're at 60.2, is 60 okay? And you know that 60 exists, correct? What if you're at, somebody said 100? Would you be concerned? Right? So if you're, because I heard Usab say 100, so if you're 100, you want to get here right away, correct? Now, are they going to slow down to 45? No, because that would be unreasonable because 45 is beyond that limit, right? But they're moving to a limit, and you know the limit is 60. They don't have to be exactly at 60, do they? In fact, they may be okay at 65. Would you agree? All right, now, let's go in the other direction. When you get on the freeway, Josh, do you accelerate?
Yes.
Okay? You don't drive 40?
No.
No, because it is
Unsafe.
it's too slow, right? So over here, if you're driving 40, my guess is when you get onto the ramp, you're not going 40. It might be a little bit too fast, right? So at some time you're 40, right? But you're accelerating and moving towards 60, correct? And based on the movement of the cars will depend whether you go a little bit over 60 or if you stay a little bit under 60. Would you agree with that? But you don't have to be 60 to know that the limit is 60. Would everybody agree? In fact, in reality, you may go a little bit beyond 60 and a little bit below 60 on your trip, depending on what the traffic is like, correct? Because then occasionally you get behind a truck and then you got to go into the left lane to go by them, and you have to wait till the cars that are going by you till there's an opening to accelerate. Would you agree with that? But so there's some type of fluctuation back and forth, but you're approaching 60 from these two directions, the left and the right. Would you agree? That was thought number one in my bike ride. And on this one, we know the limit. Here's another way. And the reason I thought of this is that we hired 2 new math teachers this way. And they're beginning to be math teachers. And I remember my first year teaching. The most difficult part is how you deal with discipline in a classroom. Because you'll see every teacher's a little bit different, correct? In other words, they have their limit. And they don't have a number for it. They just know that eventually students are reaching a point that makes them uncomfortable. Like occasionally, people call me Kruger. Well within my limit. Now, some people may call me, students call me Chuck. Now they're starting to push my limit, correct? And this could get me in trouble on the internet or in the abyss. But my first year, a student used a swear word that starts with the letter F, initially has 4 letters in it, but ended in ing. I believe that's called an adjective. And then had an inappropriate noun of which you could put an infinite number of words in there to express. They went beyond my limit. Would you agree? So as a teacher, I try to bring back those students that go beyond my limit and try to explain, you know what, that was over the line. But at the same token, I don't want students to feel like they can't ever speak in my class. And I have to allow them some freedom that will approach that limit. Does that make sense? So there's some unknown limit, and it varies like a variable. This is bothering me, these lamps. From teacher to teacher, correct? Okay. But the idea is there's a number out there that I'm approaching from one direction and another direction. It's convenient in math to say from the left and the right. Are we okay with that? All right. So that was my little intro. You can write down. Okay. And we're going to first talk about limits. We're going to talk about them two ways. We're going to talk about them numerically, which simply means using a table. I guess we don't need to look at my picture anymore. I'm going to get rid of that. There we go. We're going to look at them numerically by using a table. And that's one of the technology activities shows you how to use that at the table. I'll create a table. And actually, when you get an assignment that has a table, what I do is I put the function in the y equals 1 or y equals 2. Does everybody understand? I go to my table feature, and I put the values in there, and it figures out the answer for me. And so I can see what's happening. I will try to model that, okay? Both on a Casio and on a TI. So we have an informal definition of a limit. And a little history on calculus. There was a guy named Aristophanes that was a Greek, and he was computing areas of different shapes. And so one of the things that he was computing was computing the area, not Aristophanes, I apologize, Archimedes. So all you Archimedes fans out there, don't send me evil texts and emails saying I picked the wrong person. And he would figure out area by exhaustion. He would, actually I'm going to draw this in here because I kind of skipped the part that I wanted to talk about. What he would do is, let's say I have a curve. And I want to figure out the area of that. So what he did, he divided it into a bunch of rectangles. You know, I don't know why I didn't make anything smaller. And then would count out the area of these rectangles. Does that make sense? And this has a width, and this has a length, and that has a width, and that has a length, correct? And then he would make those rectangles smaller and smaller and smaller. And he'd get a really good approximation. It's called using, figuring out area by exhaustion. Can you, technically that is its name. Can you see why that would be exhausting? I already got tired after 3 rectangles. But what we do in calculus is we make that, this right here, a lot of people think that's a segment. If I blow that baby up, it's a rectangle, right? It has thickness and it has height. But it's a skinny rectangle. It now can be called a Kruger rectangle. Okay. So anyway, this W is getting skinnier. Now I had 3 rectangles, but what if I had a whole bunch of them? And in calculus, we call a whole bunch of them an infinite number. And I kept squeezing more and more rectangles. They would get thinner and thinner. That width would be approaching what? 0, right? At one time it might be 1 inch thick. Then it's 0.5 inches thick. Then it's 0.1 Allison thick. Then it's 0.000001. It's skinny. Right? And then it could be 0.00000000000001. But it's not 0, but it's getting really close. And what I'm doing is I'm computing the limit. And now I'm just talking about one rectangle. width times length. And then I'm going to add up all those areas together. So I add infinity. I always think people should fall out of their chairs in amazement. You're adding infinity. That's what we're going to do. Now here's how we're going to start. That thing is called a line. This is called a curve. That line has a slope, correct? How do you do the slope? I call you on your name, but I'm going blank right now.
y2 minus y1 over x2.
So in this case, 5 minus 2 over 3 minus 1. Okay, that would be the slope, correct? Well, right here, there's a line. We call a tangent line. It only touches this curve at one spot. It's kind of like when you throw a rock at your brother and hits him in the head and glances off. You know, just nicks him. Not like it causes him severe damage to get a concussion, just a little nick. Get him to bleed a little bit. Okay, you got to be really good at that. Okay, and really ticked off. All right. This line also has slope, correct? But I'm only given 1 point. So how do we figure out the slope of that? Well, what we do is we pick a point here. And this is going to be called x comma f of x. And this point here, oh, let's give it a name. Let's call it 1.5 comma f of 1.5. Is everybody okay with that? Right, this is a function that computes y, so that's the y value. We're all cool with that? All right. Well, what I do is I figure out the slope. It's going to be f of x minus f of 1.5. And it's going to be on the bottom x minus 1.5. Does everybody understand that? And then what we do is we take that point and we move it in this direction. So initially, here's my line. But as this point moves, that line starts to be moving in that direction. Would you understand that? So eventually I'm going to have f of x minus f of, well, first x is going to be maybe 2. And then it'll be 1.6. And then it'll be 1.51. And then it's going to be 1.501, and then it's going to be 1.50000001, correct? So in other words, I'm taking the limit as x approaches 1.5. Is that making sense? That's why we study limits. Simply to find the slope of a tangent line and to find the area of the curve, area underneath the curve. That's the only two things we study in this class, Ethan. Figure out the slope of a tangent line and figuring out the area of the curve. Now, why are those big ideas? Okay. I'm going to tell you 2 ideas, okay? So, I drive to this little town called Plainview, Minnesota about once every 3 weeks. Why? Because that's where my mother-in-law lives, okay? My wife and I love our mother-in-law, and we want to make sure she's doing okay, all right? When I leave, the time is 0 and my distance is 0. Does that make sense? When I get there, my time is 3 hours and I've driven 165 miles. So if I take 165 and divide it by 3, I get 55. 55 what, Ethan?
Miles per hour?
Correct. Is that the speed I drove the entire time when I went to Plainview? No, because I don't back out my driveway at 55 miles per hour. Correct? The Atkin kids would be dead. Because they're always playing, well, not anymore, they're adults now. Okay? I would kill people. Right? And my wife wouldn't be happy. There's a lot of stop and go and accelerating stuff. But was there a moment I was 55 miles per hour? Probably, right? If it's an average, there should be some numbers less than 55 and some numbers more than 55. Would you agree? So there was a moment I was 55. I had an instantaneous rate. That is the slope of a tangent line. In 6 minutes, you'll forget that, but I'm coming back to it. All right? We'll talk about that more. Okay? All right, back to these notes. So I have a little informal definition of a limit. It's going to look like this. So this means x is approaching some number. Noah, why did I choose C? It's my favorite letter. It also, I like it because the word constant starts with the letter C. That has to be a constant. It's Natalie, right? Okay. Good, I pass 2 people so far. Okay. And I'm going to have some function. So as I approach C, and I'm going to put values into F, I'm going to see that they're going to be getting close to some number. This right here is a function, and this right here is a limit. Something, and here's the key word, folks. Nick, here's the key word. Approach. When Josh is approaching 60 miles per hour, he's approaching the limit. It's the limit whether he's there or not, correct? The limit is what you approach. I'm sure there are people that are driving 60 miles per hour. They're usually the people that are 85 or older, and you can barely see the top of their heads as you go by. And they're still driving when the speed limit's 70 and everybody else is driving 75 or 80. Right? You've seen those people. Stay to the right. I'm on my way to downtown Minneapolis. Now, here's my informal definition. Now this, you will not find this in the book. This is Kruger's definition. A limit is the numerical Alex, what's numerical mean? It's a number. Numerical y value. And everybody knows that y goes up and down, correct? That's just a little hint. Because sometimes we forget. Y value as the x values, my input or domain. So up here I probably should have said output, range, draws. Remember, the y value draws increasingly closer to C. And what's special about C? It's a member of the domain. You can use it. You can use it because it's a member of the domain. So why do I bring that up? Let's say I have this function. Does f take all numbers? No. It takes every number but 5, correct? Because I'd have 5 over 0. I'm going to whisper it. 5 causes problems, right? So in 1962, there's 9 kids in a kindergarten class. There's a gal in that class named Jean. And she has a birthday and invites 7 of the 8 possible kids to her birthday party. Why doesn't one go? Because that particular young red-headed child causes problems. And the mother didn't want a problem child wrecking the birthday party. So at the birthday party, all the guests got presents. You know, they brought presents for Jean. Now, did the child who wasn't invited get a present? No. You know why? Wasn't there. Not a member of the domain. Remember that story. Semicolon. F of C need not exist. Why? Because maybe C isn't a member of the domain. Might be. Might be a member of the domain, but doesn't have to be. Let's take a look. This is called a continuous function. This is why. Would you agree that's a somewhat accurate drawing of that function? Do you see any gaps in there? Don't these arrows mean that it goes on forever just like it looks like in this way? It's continuous. There are no breaks. So if I put numbers in here, and I've already done this, if I put this number in here, I get 6.7. This number would be 6.97. This number would be 6.997. If I put 2 in there, I get 7. So I'm approaching from the left. Would everybody agree? So right here is 7. Right here is 2. As I move along this x-axis, as I go there, I'm hitting all these y values. And they're increasing. And right here is 7. I'm getting closer to that 7, correct? And over here, if I put in 2.1, I get 7.3. And if I put in 2.01, I get 7.03. And if I put in 2.001, I get 7.003. So over here, I'm approaching in this direction. I'm approaching from the right. I'm approaching from the right. All my numbers are bigger than 7 on the right. I could have started at 15, but 15's not very close. It's like being on 100 on Highway 15. That's not good, is it? There's a highway patrol person sitting there. I'd rather be at 61. I'd rather be at 65, hoping that highway patrol had a good day. That breakfast was good. So approaching. Now, what does this look like? Looks like the limit as x approaches 2. Now, notice this. I'm going to write a minus sign to the right and upper right of the 2. That's my constant. That means I'm approaching 2 from the left. And in this case, as I approach, let me write 3x plus 1. From the left, I'm going to get 7. Over here, as I go in this direction, I'm going to write the limit as x approaches 2, and then I'm going to put a plus sign there. That means from the right. And so it's going to have y values. They're going to be a little bit bigger. Notice how I am demonstrating on a graph the limit. That is important on the next quiz. That is important on the next quiz. All right, let's take a look at this one. In this case, f of x is this. That is called a rational function. Does that make sense to everybody because it's in fractional form? And I'm approaching a -1. Notice how I'm getting closer to -1. Is it obvious? And when I plug in a -1, what do I get? If I put -1 in here, I get 1 plus a -3 plus 2. I get 0 on top, don't I? What do I get on the bottom? 0. I don't get a y value, do I? So what I'm going to write here is d n e. Ah, somebody said it. Will you say it louder, please? So the people out there, I'm hoping we have the DeMars clan, you know, the daycare people listening. Okay? So say it loud, Allison.
Does not exist.
Does not exist. That stands for does not exist. Why do we write DNE? For the same reason we have letters. Math teachers can't spell. One time we only had 8 teachers in the math department, and we were all together, and I was working on the computer, I was typing something in, and I said, oh, and I didn't do spell check. I just wanted to see, I figured it'd be faster, because I was using a machine, right? You know how inept I am with the machine. And I yell out, how do you spell so-and-so? I wish I wrote the name down. I wish I wrote the word down. I got 7 misspellings. Why do we use letters in math? Because we're terrible spellers. That's why we go D&E rather than write the word does not exist. Too complicated to spell. So I put these numbers in. I got 0.9. I got 0.99. I got 0.999. I approached from the left, didn't I? I approached. By the way, Ethan, all the numbers got invited to this function's birthday, except for one number, -1. And they all got gifts. But the gift for the -1 does not exist. Just thought I'd tell you that story. Okay, 1.1, 1.01, 1.001. So the limit as x approaches a negative 1 of f of x from the left, notice how it's from the left? Can you see that okay? No, it looks terrible. Can you see it now? So as I'm approaching, I get 0.9, I get 0.99, I get 0.999. That is not my limit. Because I could get even closer, correct? What is my limit? What am I approaching? Say it louder?
-1.
No. Okay, excuse me, I'm sorry, I said it wrong.
1.
What is my limit getting closer to? 1. That's my fault. I'll bear the responsibility. Okay. Now, as the limit as x approaches negative 1 from the right of f of x, what does it equal? So as I'm headed here, I'm heading from the right. I got 1.1, 1.01, 1.001. That is not my limit. I had 1/3 of the class last year write that down. It was the last number I wrote down. That must be it. Well, then why didn't you write that one down? Austin, what's my limit?
1.
Isn't there an Austin in here?
Just kidding.
Oh, I didn't know. 1.
1. Okay? Now notice, the limit as x approaches negative 1 from the left of f of x equals the limit as x approaches negative 1 from the right of f of x. So we have a left-hand limit, we have a right-hand limit, and when they're equal, we have what's called the overall limit. Does that make sense? And if this is asking for the overall limit. Why do I know that? There's no plus or minus to the right of it. And these limits have to be the same. Does that make sense? Now, if I would graph that, you would see that this looks like, well, we could do a little analyzation here. And so I'm giving you a little heads up. Savannah, can you factor that? I believe that's what you said. I forgot my hearing aids at home. Is that correct? Bam! Right? Right? Because for all the values but a negative 1, I can do that. Would you agree? So, if I look at the limit of this, that's a simplified version. These two are not equivalent. Madeline, they're not equivalent. Do you know why they're not equivalent? Okay. Jean had a twin sister, Margie. They looked exactly the same. Margie wanted to invite the little red-headed boy because she thought he was cute. And in kindergarten, they would hold hands. She was the only one that could calm down that little red-headed boy. Now, is she identical to Jean? Jean doesn't want the little boy. But Margie does. So in other words, I can put a negative 1 in here, can't I? So these aren't equivalent. They're equivalent for every single value, but the little-headed red boy we call a negative 1. Correct? Can't go here, but can go here. So I can use this to know what this is approaching. If I plug a negative 1 into here, I would get 1, correct? Now, what does this graph look like? It looks like Gene and Margie look the same, except at right here. What do we call this thing? We call it a hole. But it has a limit, because as I approach left and as I approach right, here's a negative 1, or as I approach a negative 1, I'm getting closer to 1. Is that making sense? This is solid. This has got a hole in it, because that negative 1 isn't part of the domain. It doesn't exist. Did you talk about holes last year? Okay. Next page. We doing okay? Piecewise graphs. So this is how I draw piecewise graphs. I look at where x is 2. 1, 2. There is no line underneath this lesson symbol, so I'm going to draw an open circle, correct? And I'm going to plug 2 in there, and I'm going to get 7. And I'm going to the left, because all the x's are left, and it has a slope of 3. So it looks like that. That's this part. Everybody cool on that? Check that baby off. I did that. This is how I took the quiz when I was in college. Because I was scared of piecewise graphs because they were not pieces of pie, and I liked pie. So when x equals 2, I'm at 3. That's about right there. I'm not at 7, am I? I'm at 3. And then when I'm greater than 2, I have an open circle at 2. And it looks like this. It's got a hole. So this is a party. This little redheaded boy went to a different party. He's the only kid there. Two is part of the domain. We just don't use this part of the equation to compute it. Does it make sense? It's kind of like when you play a board game and you hit that particular spot and you got to go back 3 places. It's not continuous, right? Or you collect $200. All right, so if I plug numbers into here, it looks like this. This is going to be 3. Why is it going to be 3? Because that's how I define it right here. Bryn, are we okay with that? Okay. So if I plug numbers in, I'm going to get 6.7, 6.97, 6.997. I'm approaching from the left. Adam, am I approaching 3? No, I'm approaching what?
7.
I'm approaching 7, correct? Because I don't care what I am at 2. I want to know what I am when I'm getting closer to 2. I'm going up there. It just means if I'm 2, I got to go 4 back, right? So when I plug in these numbers, I get 7.3, I get 7.03, I get 7.003, correct? Aaron, am I approaching 3? I'm approaching what? 7. Because as I'm approaching this way, I'm way up here. Correct? And so what's my limit? My limit is equal to 7. Because a limit is what you're approaching, not where you're at. The speed limit means if I see that police officer, I better be somewhere around 60, correct? I don't have to be exactly at 60. And my guess is really there's a certain amount of error on that speedometer anyway, right? Because it was manufactured and it has to be accurate within a certain amount of specifications. Is that making sense? Let's take a look at this one. So this was a piecewise graph. This has an asymptote in it. I can't simplify the asymptote, can I? You could if you were a voodooist, and it'd be wrong with a stamp. Addie, what am I going to put in at a -1? Did you say does not exist? Okay. I got to remember my hearing aids. Okay. I would have 3 over 0, right? So now, how do I know I'm approaching a -1? Because these numbers are getting closer to a -1. Over here, these closers are getting closer from the -1. I set up my table so that there are numbers to the left and the numbers to the right. It helps me think about that. So if I plug in those numbers, I get a -32.1. I get a -302.01. I get a -3002.001. Okay, I'm going to try it today. I don't have a great deal of confidence, Sama. Sama. God, it's that accent. Sama. As I'm approaching from the left, the limit as x approaches -1 from the left of f of x, how would you describe what is happening? I'm at a -32. Then I'm at a -302. Then I'm at a -3002. What's happening to my y values? It's going what? Yeah, that might be the case. I think there have been argument for that. I agree. Okay, it's continuous, right? Where would you expect the next one to go if I looked at it on a graph? So this is what I know for sure. Right here, I've got a dotted line, right, at x equals a -1, correct? I'm over here. I'm approaching this way. Tell me what to do here. Do I go up? Do I go down? Looking at these numbers. Down. And so where is this graph headed? I'm going to put an arrow here. Positive or negative? Negative, okay? And those numbers are becoming more and more negative. It's going to negative. Does anybody have an idea where I'm trying to lead her? Negative infinity, or what I call HE double toothpicks. Now, let's take a look at the right. I believe I have 28.1. Then I have 299.8. That's an 8001. I did not make these big enough. 2,998.001. So I'm coming from the right. I'm positive, right? And then I start to swoop up. Would everybody agree with that? Sophia, would you agree with that? Where am I headed? Positive infinity. It's like two ships passing in the night. You ever hear that poem? All right, so what's my overall limit? Morgan. Are they headed towards the same number? No. So if they're not headed towards the same number, what do you think our limit is? Okay. Anyone want to take a shot? Alex. There is none. Right? As I get closer, this will probably be up to 29,000. This will be at a negative 30,000, correct? They're headed away from each other. So, how do I write there isn't one? D, N, E. Notice 3 letters. Okay? We doing okay? Right? Because tomorrow gets a little bit more complicated. Alrighty. So, functions with jumps. Now, I don't know if I said that. You see this thing right here? Let's say there's a little man. Let's say that man is me. I got a beard, I got glasses, okay? And I'm walking this way, okay? I could step over the hole. Would you agree? Right?
Yes.
I could step over that hole. I step over holes all the time in my backyard. There might be a post hole. I could step over a post hole. Right? Okay, now let's take a look at this. I'm going to draw this one. Here's 2. Open circle. Here's 7. Goes down like this. Are we okay with that drawing? It's not perfect. Positive slope, slope of 3. Okay. Then I've got this. And not scaled correctly. Just saying. Okay? Because I did this one, right? And now it's this one. When I'm at 2, and I put that in here, I'm going to have an open circle. I believe that's a negative 5. Would you agree with that? And if I put a 3 in there, I'm going to be at a negative 8. So I have a negative slope that goes this way. Right? That's a function. Passes the vertical line test. Are we cool why this one goes positively and this one goes negatively? Now, notice I made a cliff. Here I am. And I'm walking this way. I'm going to have to jump down. Right? Kapoom. Or if I'm coming this way and I'm walking this way, I'm going to have to jump up. I suppose I could jump here and then grab a hold of that thing and get on it, but I'm going to have to do some jumping, right? This is called a jump gap. It's different than a hole. You can step over a hole. I've done it all the time. And I used to do a lot of jumping when I was a kid. When you get older and you jump, it hurts. I don't like jumping. I'm not as nimble as I used to be. And if I took look at the limit going this way, where am I approaching as I'm going on my picture, as I'm coming from the left? Where am I headed? Am I headed to 3? Not sure? Adam, are you sure?
Should be -2.
Should be what?
Should be -2.
Yeah, as I'm headed to the 2, what's my limit approaching? What's my limit becoming? As I approach 2 from the left, okay? As I'm approaching 2 from the left, my y value is getting very near what number? I don't think so. I think if I plug these numbers in, and here are the numbers I plugged in 1.9, I plugged in 1.99, I plugged in 1.999. I know when I plug in 2, I get 3. What I got here was 6.76, 6.97, 6.997. Right? Because as I'm going here, I'm getting higher, right? I actually go past 3. Okay? And so I'm headed towards 7. Does that make sense?
Yeah.
Okay? And now over here, if I put in these numbers, 2.1, 2.01, 2.001, I'm going to get a negative 5.3, a negative 5.03, a negative 5.003. So as I'm coming this way, my y values are down here, but they are rising, aren't they? Correct? Give me your first name. It's been bothering me.
Becca.
Becca. Becca, what am I approaching?
-5.
-5. So I would write down the limit as x approaches 2 from the left of f of x. That's 7. The limit as x approaches 2 from the right of f of x. That's a -5. So Becca, right here, what's my limit of f of x as x approaches 2? What's my L? Are they headed towards the same number? No, they're not. Do they have to? Yes, they do. They have to. And if they don't, what do I write down as an answer? Does not exist. Are we doing okay? So I want to summarize. I know we're not done. We'll finish tomorrow. Okay? You should be able to start doing some of the work. Okay? Notice I say the word sum. Now, a limit is you have to approach from the left and the right, correct? And it has to be the same number as you approach. Does everybody understand that? You are guaranteed a limit if the function is continuous. You are guaranteed a limit if the function is continuous. That means there are no breaks. When else are you guaranteed a limit? If you have a break and the break is a hole. A hole. The other two kind of breaks can be asymptotes and jumps, and there's no limits for those. Is that making sense? So if I look at tomorrow, we're going to look at some graph problems. This is a piecewise graph. This is a piecewise graph. This is a piecewise graph. Would everybody agree? These are directly from AP tests on the multiple choice portion. And you can see a jump, correct? Doesn't that look like a jump? A jump. A hole. A jump. A hole, another hole. We'll see you tomorrow. Thank you.